Hi, I'm Jace Rawlinson. I'm in CHEM 117, Section 404, and today I'm going to be going over and demonstrating Charles's Law. Charles's Law is one basic relationship, and that is the relationship between the volume and the temperature of a gas in a container. And the relationship is a direct relationship. Let me see if the paper will cooperate with me there. Awesome. All right, so that means that we can derive from that if we take, so in a system where the temperature or the velocity, or the volume, are the only things changing, if pressure, if the number of moles of the gas are the same, then this is the relationship between volume and temperature. So you got volume 1, or the initial volume over the initial temperature is equal to the initial, or the final volume over the final temperature. Or if we just rearrange that for volume, which is going to be pertinent to the experiment that I'm showing, you got the final temperature times the initial volume over the initial temperature is equal to the final volume. Alright, so here we are. We are in my extremely high-tech lab. So remember, kids, don't do this at home. I'm at one of the labs on campus, one of the most sophisticated in the world, actually. So what we got here is we have a pan with some water in it, a can with some water in it, and here, this, you can't see it because my camera angle is limited, is a whole bunch of really cold water. Alright, so what's going to happen is that it's going to go from very, very hot inside this can to very, very cold inside this can. And it's going to collapse because, like I said earlier, if the temperature drops, the volume has to drop as well. Alright, so remember, don't try this at home. Oh, it barely worked, but it did. See that? Just a little bit of volume change, but it did suck up a bunch of the water.